My dear friends, welcome to Rajashekar classes on applied data science with Python. In this lecture, we will try to understand one simple problem on hypergeometric distribution. First, we will try to understand problem. Different computers are checked from 10 in the department. 4 of the 10 computers have illegal software loaded. What is the probability that two of the 3 selected computers have illegal software loaded? First, here you must understand, by looking at the problem, we are feeling that it is finite population. This point is important. It is related to finite population. As we were discussing in previous lectures, if it is finite population, you can think of finite population without replacement. You can think of hypergeometric distribution. Here it is finite population. I can say whenever there is a finite population, we should think of hypergeometric distribution. So, what is my capital N? Capital N is given. N is your population size. Is it not? What is the size of the population? Just check. Different computers that are checked 10. Total number of computers in the department is 10. Therefore, my population size, capital N is population size, that is 10. And A equal to 4. What is my A? A is the number of successes in population. Therefore, number of successes in population means 4 out of 10. This is my N. This must be my A. Why? Because 4 out of 10 means my A is number of successes in population. That is my A. We know what is A. We know what is N, isn't it? 4 computers have illegal software, because we know how much illegal software is installed in the population. There are 4 systems in which illegal software is installed out of 10 systems, means in the population size is 10, and whereas A, as I told you, my capital A is number of successes in population. What is the probability? What's the question here? What is the probability 2 of the 3 selected computers? What does it mean? You have to find probability for 2 means this is small x equal to, x is number of successes in sample. What is my sample size? Small 3 is sample size, isn't it? Small n equal 3. What is the probability? First you must understand these variables. What is the probability that x equal to of the 3 selected computers will have illegal software loaded? So your x equal to 2, isn't it? It's straightforward. Just read that problem and understand and identify variables. There are 2 things. One is for population. I can say like this. Let me say like this. This is let me say population. Yes, there is something like population and sample. Let me draw it like this. This is my population. What is my sample? There is sample. This is my sample. Otherwise, let me, yes. Now just see. What is my sample? This is my sample. What we know? What is population size? Capital N equal to 10. How many successes are there in population? Capital A equal to 4. What is my sample size? N equal to 3. Out of 3, what you have to find? You have to find small x, 2 successes. That's what he is saying. What is the probability of 2 of the 3? Isn't it? 2 of the 3 selected computers. That's the basic meaning of this problem. Anyway, we know what is a problem formula. P capital X equal to X. What is my formula? P capital X equal to X. This capital X is ACX. What is my A value? A value is 4. AC. What is my X value? This I can say P capital X equal to small x. If I say small x, this you can write. That is, it's an understanding. ACX. What is my A value is 4. X value is 2. 4C2. N minus A. What is my N? N is 10 minus A means what? 10 minus 4, that is 6. N minus X. What is my N minus X? 3 minus X means 2. 3 what is my X? X is 2. 3 minus 2, that is 1. 6C1 by capital N is 10, small n is 3. That is 4C2. This you can just, it's a matter of calculation, simple calculation. What is my 4C2? 4C2 means I can say 4 into 3 by 1 into 2, 2 1 ja, 2 2 ja, that is 2 3 ja, 6. 6C1 is 6, isn't it? Therefore 6. 10C3, how can I calculate? 10C3 equal to 10 into 9 into 8 by 3 means 3 into 2 into 1, isn't it? Therefore, how can I calculate? 2 4 ja, and I can say 3 3 ja, 3 4 ja, 12. 12 into 10, 120. This one can calculate this. That is 0.3. What's the meaning? How can I interpret this result? How can I interpret? Yes, I am getting 0.3 means the probability of 2 of 3 selected computers will have illegal software is 0.3 means that is 30%. Let me calculate few more things for this particular problem. Let me say like this. If you are interested in finding mean, I already discussed the formula for mean. What is my mean formula? Just let me recall, just refer my previous lecture. That is, maybe I think it is 116, lecture number 116. In that lecture, even if you are interested, you can find mean. What is mean for hypergeometric? Mean mu equal to capital A into small n by capital N. These parameters I already discussed. What is my capital A? Capital A is the number of successes in population. Small n is sample size. Capital N is population size. We know what are these parameters. What is my capital A value? 4 into small n value is 3, isn't it? By capital N is 10. 12 by 10 means it's 1.2, isn't it? That's mean. How can I calculate variance? We know formula for variance. We already discussed in lecture number 116. My variance formula is capital A into n minus A into small n into capital N minus n by, I can say, n square into n minus 1. We know all these parameters. Just it's a matter of substitution. My capital A value is 4 into capital N value is 10 minus capital A means 4 into small n is 3 into capital N minus n. My capital N is 10, small n is 3, 10 minus 3 by, I can say, n square into n minus 1, 10 square into 10 minus 1. Just if you simplify this one, you will get 504 by 900 you will get. That is essentially 0.56. This is sigma square. This is variance. This formula I already discussed in lecture number, I think it's lecture number 116. Just refer that lecture so that you can understand. This is one simple example on hypergeometric distribution in which you can identify probability of 2 or 3 selected computers have illegal software loaded. Not only that one, you can also calculate mean, variance and standard deviation. Thank you very much. I will discuss about another distribution, famous distribution, uniform distribution in my next lecture. That is in lecture number 119. I will discuss about discrete uniform distribution. Then in lecture number 120, I will discuss about continuous uniform distribution. Thank you very much.